In this tutorial, we will be making a simple motor speed controller using the Arduino. First, we need to understand how a motor works. A motor's speed is equal to the motor speed constant, also known as kV, times voltage. For example, the kV of the motor I'm using is 500 RPM per volt. That means for every volt supplied to the motor results in the motor spinning 500 RPM faster. By controlling the voltage, we can control the speed of the motor. The Arduino has 6 PWM pins. These are pins that can simulate a range of voltages from 0 to 5 volts. Thus, you may be tempted to hook the motor straight to the Arduino with one end of the motor on the PWM pin and the other end of the motor on ground. However, this won't work. Firstly, the PWM pin can only control voltages up to 5 volts. The maximum voltage for this motor is 12 volts, which would be impossible to reach. However, there's an even greater problem with this approach. An Arduino PWM pin can only supply a maximum current of 40 milliamps. On the other hand, this motor is capable of drawing up to 850 milliamps. This would certainly damage the Arduino. That means we're going to need an external power supply, also known as a battery. I am using a 1-cell lithium polymer battery. It only goes up to 4 volts, which doesn't matter for the sake of demonstration. What does matter, however, is that the battery is rated to supply up to 15,000 milliamps, or 15 amps of current. That's more than plenty. Then we are going to need a way for the Arduino to control the voltage of the battery. For this, we'll use a MOSFET, specifically the IRFZ44N. This device has 3 pins. From left to right, they are called gate, drain, and source. A MOSFET works as a variable resistor. By controlling the voltage between the gate and source pins, we can control the resistance between the source and drain pin. First, connect one of the Arduino's PWM pins to a more convenient location. Then connect the gate of the MOSFET to the PWM pin. After that, connect the drain pin to the column on the other side of the breadboard. This will later connect to a negative terminal of the motor. Next, connect the positive power rail to a column near the first column. This will later connect to the positive terminal of the motor. Connect the source pin of the MOSFET to the negative power rail to complete the loop. Lastly, connect the Arduino's ground terminal to the negative power rail, and connect the motor to the 2 columns we set up earlier. Add jumper cables to the power rail so that you can plug in the battery. We are finished with the basic circuit, but there are still a few things we can add. First of all, even when the Arduino's PWM pin value is set to 0, it still outputs a very small amount of voltage. This causes the MOSFET to unintentionally allow a small amount of electricity through. To fix this, we can add an electrical connection between gate and negative power rail, neutralizing the small amount of voltage from the Arduino. However, if we use a standard jumper cable like this, when we turn on the PWM pin to control the motor, this will short circuit the Arduino. To fix this, we will use a high-value resistor instead. That way, the gate pin is still neutralized without shorting the circuit. This is called a pull-down resistor. Secondly, when the motor is turned off abruptly, it can generate a high voltage, which can damage the MOSFET. To protect against this, we can add a diode in reverse, called a kickback diode. Now we have a working motor controller. Write the following code and upload it to test.